and clean water, and also even break down hydrocarbons. And at the same time, literally the major transducer of Earth's temperature are the interactions of plants with the surface of the Earth itself and the light that comes in. The Earth is covered between 3 and about 12 times with plant leaves as they're structured over the landscape itself, and that literally partitions energy to make the Earth cooler. So we've centralized a great number of things and made for basically efficiencies of scale, so-called. But the problem is that comes with a cost, because the capacity to filter water and to enhance the landscape depends upon what are called ecosystem services: the cleaning of water, the cleaning of air, the improvement of environmental quality. And like justice, those probably have to be distributed as opposed to centralized. They need to be literally everywhere where pollutants, where materials are dumped into the landscape. The filters need to be in the same places to literally do the work of cleaning the environment for us. Prosaic terms, water is a principal solvent in the biosphere, and literally its chemical properties, by freezing and thawing and evaporating, make life possible. Regulate the Earth's temperature so that it's favorable to all of us. And by all, I mean all beings. So we've centralized too much in New York City, and we're starting to do otherwise, and more on that in just a bit. But green infrastructure, evaporation, water equals power, and by that I mean something very specific. Every half centimeter plus of water that evaporates over a hectare is the equivalent of about 15 tons of dynamite exploding, the same energy. Literally, that energy from this much water, from part of a centimeter to something close to 3 meters plus tall in vapor phase. And that literally takes the energy from the Earth's surface and distributes it, airmails it to elsewhere to come down as rain. For every hot city, every 33 gallons of water that you waste down the sewer is the equivalent of a ton of air conditioning. It literally can drop the temperature of something like 400 square feet by enough degrees to make it comfortable. Obviously, we need to play with relative humidity, but in terms of temperature regulation, it's the leaves partitioning heat into the atmosphere and getting rid of latent heat. The same side, that 33 gallons of water is also the capacity to fix something like a part of a pound of carbon in the ecosystems that support all of us. It's hard to see the national boundaries on this picture. I don't notice. Maybe they're not there. Water doesn't respect them. That basically covers the entire planet, and we need to recognize that it's an interconnection. And I appreciated, I think it's Donna Barry's point earlier, that there's a national interest in water, not to mention an international one, as well as a locale altogether. So we've learned a few things in New York. It's a rich city, but it's made decisions that seem crazy at the time, like putting a park in the center of an urban area. It happens that park raised real estate values, which Olmsted said right away, but also, literally, it's one of the cooling engines of the city itself, and it makes the environment, the ecology, the literally energy use neighboring to that park lower. And any park will do that. They're starting to build parks in Japan up gradient from center cities, and the cool air that comes from them actually drives the hot air away from the central village. Works most any place that physics works. We also learned really by hard error that we need to connect parkland into ecological and green corridors. But you notice there's failure here. The North Bronx has got the most parks of a city, any city in the world, and the South Bronx has virtually none. And there are new plans actually to change some of that, but we had some of it right. And you can see on the left the New York City, the original water supply on the right side, east of Hudson Croton, and the west of Hudson Cat Dell. Really, New York is one of the richest parts of the earth, maybe the richest, because we have this exquisite watershed that covers really the weather that comes from the Caribbean, from the Gulf of Mexico, from the Northeast, and from Canada altogether. So if anybody's going to catch rain and precipitation, we are. Precipitation, and you can see New York State really is a gold mine if water is gold, and it's about as close as you get in the world of human community. The other side of it is we also have done a great deal with pipes, and pipes guarantee that pollutants will not be filtered. You can see combined sewers here, 27 billion gallons each year dumped into our surrounding estuaries. But we have a mayor, and this is where both bottom-up and top-down planning are, I think, essential. We have a mayor who's actually changed the game. We're throwing all of our waste plastics and waste glass and waste metal away. John New walked into the mayor's office and said he would pay him for that material, and we suddenly became a recycling city. And about 25% of material is recycled. Same thing for stormwater, and there's a plan now to actually change the city, but it will only occur if we can actually work from both sides, from bottom down, bottom up, and top down. So Plan NYC is really a worthwhile document, but it's going to be also things on the street. This is the first, basically, building that's cooled with processed water. They have they make parts for NASA and Boeing, and they have to run the building around 70, 74 degrees because of the coefficient of expansion of metal. And basically, putting a green roof on last year allowed this to support a native plant meadow. And every 1 degree that you drop the intake air of that air conditioner, it will work in any country or any part of the world, will increase the efficiency of that air conditioner by 1%. A 30-degree difference between a black roof and a green roof going into the air conditioner intake will increase the efficiency by something like 30%. The gentleman who runs this facility saved 50%, he says, of his air conditioning last year after the green roof was put in place by taking the wastewater from his metal cutting tool and shipping it onto his roof to evaporate it in the plants you see here. So the point is that something that was a problem can become something very different by putting small terraces, which people invented in the Alps, in the Andes, in China, all over the world 10,000 years ago. These are micro things, about 1 inch to 2 inches tall, 10 centimeters, 5 centimeters. And they hold small reservoirs under that wetland you just saw. And basically, looking something like this, it makes it possible for the water to have some residence time on the roof. You could also use it for treating wastewater, for treating black water, for treating processed water, to literally make your roof into a cooling enterprise in any country, and not any climate. You have to have relative humidity that's favorable to evaporation, but certain times of the year it can certainly work. This is the equivalence I told you about before. This much water goes to something like 3 meters plus when it evaporates, and as we all know, if you throw 100 cubic centimeters of water over your shirt during the summer, you cool off by about 1 degree or 2. It's just physics, but it works everywhere, and it works because plants partition energy into sensible heat, the kind of heat you see boiling off your toaster or off a hot road, and latent heat, which is airmailed as water vapor to come down as rain someplace else. So really, we need to rethink the way we put our technologies together. And trained in ecology, of course, you only see what you're taught to see. I'm going to say there's only 3 measures. If you build something, it should increase, at least leave without harm, but better to increase biodiversity, ecological productivity, and ecosystem services. Biodiversity, how many kinds of beings per square meter, square kilometer, square whatever. Ecological productivity, how much stuff you're capturing per square whatever. Should be at least 1 kilogram if you've got water per square meter, up to about 10 for a good wetland system or a good rice paddy. Ecological productivity, second measure. And in ecosystem services, how much water and air are you cleaning with what you build? The size of buildings, the parkland should be coupled with our dwellings so that they're actually close enough to make a difference for people to learn and play, and also to clean exactly the fluids that support us. So really 3 laws in ecology: the flow of energy, the cycle of materials, and the development of systems. And really, with the Bangladesh issue, if we have these 3 atom molecules in the atmosphere, every 3 atom molecule is necessarily an antenna for heat capture. So you have 5/6 of a chance that it's going to stay in the atmosphere, 1, 2, 3, 4, 5, and 6 going out. It has to be, we will catch heat, whatever the administration here used to say. So this is the path we're on. On the right is the path we need to get onto. And one of the ways to do this, almost everywhere on the planet, is to actually couple our wastewater, our waste organics, which can be made into compostable materials, increase the organic and the friability, the capacity of water, of soils to hold water. In New York, we have much, much more. Of course, we have a lot of things, and we waste a lot of things here. This was is a recycling facility on the Bronx River. Basically, it was unpaved, so they had to stop work during bad rainstorms. By putting some effort into catching water on site, I'm sorry, let me get past it. They're able to catch now a fairly large amount of water. More on that in a second. A little bit out of order here. I don't know how I did this. Let me actually just do this, and I'll go back to the other story in a second. in every locale where you pay for energy,